Hello there, and welcome to tonight's journey through the cosmos. As you settle into your favorite spot, perhaps pulling a blanket a little closer or adjusting your pillow just right, we're going to drift together toward one of the most magnificent and peaceful worlds in our solar system. Saturn, that jeweled giant floating in the darkness, holds secrets and wonders that seem almost designed to soothe the restless mind. Tonight we'll explore the gentle mysteries of this ringed world, where everything moves with an ancient, unhurried rhythm. From the delicate dance of its countless moons to the whisper-thin ice particles that form those famous rings, Saturn offers us a masterclass in cosmic serenity. Each fact we discover will be like finding a smooth stone on a quiet beach, perfect for turning over in your mind as you let the day's tensions dissolve. If you're someone who finds peace in learning about the vast universe around us, you're in exactly the right place. Feel free to like this video if these cosmic explorations help you unwind, and consider subscribing for more gentle journeys through space and science. But for now, all you need to do is breathe slowly, let your thoughts settle, and allow yourself to be carried away by the quiet majesty of Saturn. Saturn spins through space with the grace of a cosmic ballet dancer. This massive world completes one full rotation in just 10 hours and 39 minutes, making its day less than half the length of ours here on Earth. Imagine watching the sunrise and sunset twice in a single Earth day, with Saturn's gentle golden clouds shifting and swirling in an endless, mesmerizing pattern. What makes this rapid spin even more remarkable is how it shapes the planet itself. Saturn is not a perfect sphere, but rather bulges outward at its equator like a soft cushion, gently pressed at the poles. This oblate shape gives the planet a comforting, rounded appearance, as if the universe itself crafted Saturn to look as welcoming and peaceful as possible. The planet's quick rotation creates winds that flow in smooth, organized bands around the globe. These aren't the chaotic storms we might imagine, but rather steady currents that have been flowing for millions of years in predictable patterns. Think of them as cosmic rivers of gas, each following its own ancient path around Saturn's middle, creating a sense of order and rhythm that's deeply soothing to contemplate. Saturn's density is so low that it would actually float in a cosmic ocean. This gentle giant, despite being the second largest planet in our solar system, has a density less than water. If you could imagine a bathtub large enough to hold Saturn, this massive world would bob on the surface like a cork, creating the most extraordinary sight in the universe. This incredible lightness comes from Saturn's composition. The planet is made primarily of hydrogen and helium, the same elements that filled the universe shortly after the Big Bang. In a way, Saturn is like a preserved piece of the early cosmos, a gentle reminder of the simple, peaceful state from which all complexity eventually emerged. The thought of such a massive world being so light and buoyant adds to Saturn's dreamlike quality. It challenges our earthbound intuitions about weight and density, inviting us to imagine a universe where even the largest objects can float with ethereal grace. There's something profoundly calming about this idea, as if Saturn itself is teaching us that even the heaviest burdens in life might be lighter than we think. Saturn's rings are not solid, but rather composed of countless individual particles, each one dancing in its own orbital path. These particles range in size from tiny grains of dust smaller than a marble to house-sized chunks of ice and rock, all following the ancient laws of gravity in perfect harmony. The rings extend outward from Saturn for hundreds of thousands of kilometers, yet they are remarkably thin, sometimes only a few meters thick. Imagine looking at Saturn's rings edge on and seeing them nearly disappear, like viewing a sheet of paper from the side. This incredible thinness gives the rings an almost magical quality, as if they're made of crystallized moonbeams rather than solid matter. The particles within the rings don't collide chaotically, but rather follow gentle, predictable orbits, occasionally nudging each other in slow, graceful interactions that have been continuing for millions of years. Each ring particle is essentially a tiny moon, following the same fundamental principles that govern the motion of planets around stars. They shepherd each other through gravitational influences, creating gaps and structures within the rings that remain stable across vast spans of time. This cosmic choreography operates on such a grand scale that it becomes a meditation on the beauty of natural order. The temperature on Saturn hovers around -178 degrees Celsius, creating a world of permanent winter that somehow feels more peaceful than harsh. This extreme cold means that water exists only as ice, and many other substances that are liquid or gas on Earth become solid crystals in Saturn's environment. In this frozen realm, changes happen slowly and gently. Weather patterns that might be violent on warmer worlds become subdued and graceful on Saturn. The cold acts like a cosmic sedative, slowing down molecular motion and creating an environment where even the atmosphere moves with measured, unhurried rhythms. This perpetual winter gives Saturn a timeless quality, as if the planet exists in a state of eternal, peaceful hibernation. The cold preserves everything in a kind of cosmic amber, where processes that might be rapid and chaotic elsewhere unfold with the patience of geological time. It's a world where urgency has no meaning, where everything happens in its own gentle time. Saturn has at least 83 known moons, each one a unique world following its own peaceful orbit around the giant planet. These moons range from tiny, irregularly shaped rocks just a few kilometers across to substantial worlds like Titan, which is larger than the planet Mercury. They form family a complex, each member maintaining its own character while participating in the grand orbital dance around Saturn. Some of these moons are shepherds, using their gravity to keep Saturn's ring particles in line. Others are captured asteroids that found their way into Saturn's gravitational embrace and decided to stay. A few are thought to be fragments of larger moons that broke apart eons ago, their pieces now forming small families of related objects that orbit together like cosmic siblings. The largest moons follow nearly circular paths, their orbits as smooth and predictable as clockwork. They've been following these same routes for billions of years, never deviating, never hurrying, just maintaining their steady progress through space. There's something deeply comforting about this reliability, this cosmic punctuality that continues regardless of what happens elsewhere in the universe. Titan, Saturn's largest moon, possesses a thick atmosphere that creates weather patterns remarkably similar to Earth's, though with methane instead of water. Clouds form and dissipate, rain falls, and lakes fill and evaporate in cycles that mirror our own planet's hydrological processes. This familiar pattern, playing out in such an alien environment, creates a bridge between the known and unknown that feels both exotic and comforting. The methane rain on Titan falls gently through the thick atmosphere, taking much longer to reach the surface than rain does on Earth. These slow, languid drops create a kind of cosmic meditation on the nature of weather itself. The lakes they fill are calm and still, their surfaces reflecting the dim light of the distant sun in ways that would create hauntingly beautiful scenes for any observer standing on Titan's shores. Titan seasons last for about 7 Earth years each, creating a world where change happens on a scale that encourages patience and long-term thinking. Spring arrives slowly, summer lingers, autumn extends for years, and winter settles in for the long term. This extended seasonal cycle creates a rhythm of life that operates on a completely different timescale than our hurried earthly existence. Enceladus, another of Saturn's remarkable moons, harbors a hidden ocean beneath its icy surface. This subsurface sea contains more water than all of Earth's oceans combined, existing in permanent darkness beneath kilometers of ice. The ocean is kept liquid by tidal heating, as Saturn's gravity gently kneads Enceladus's interior, generating just enough warmth to maintain this hidden aquatic realm. From cracks in Enceladus's icy surface, geysers of water vapor and ice particles erupt into space, creating a thin atmosphere around the small moon. These eruptions are not violent explosions, but rather gentle releases of pressure, like a cosmic sigh that sends crystalline droplets arcing gracefully through the vacuum. Some of these particles fall back to Enceladus's surface as snow, while others escape to become part of Saturn's ring system. The hidden ocean of Enceladus represents one of the most peaceful environments we know of in the solar system. Protected from radiation and temperature extremes by its icy shell, this dark sea maintains conditions that have remained stable for millions of years. It's a world within a world, a sanctuary of liquid water in the cold depths of the outer solar system, where any life that might exist would live in perpetual twilight, undisturbed by the chaos of the surface world above. Saturn's magnetic field extends far into space, creating an invisible bubble of influence that protects the planet and its moons from harmful cosmic radiation. This magnetosphere is like a gentle shield, deflecting high-energy particles that stream from the sun and deep space, ensuring that Saturn's delicate ring system and diverse collection of moons can exist in relative safety. The magnetic field lines curve gracefully around Saturn, creating elegant patterns that would be visible if we could somehow see magnetic forces directly. These field lines guide charged particles in smooth spirals, creating auroras at Saturn's poles that dance with ethereal beauty in the planet's upper atmosphere. Unlike the often dramatic auroras on Earth, Saturn's auroral displays have a more subdued, contemplative quality that matches the planet's overall serene character. This protective magnetic embrace has been shielding Saturn's system for billions of years, maintaining the stable conditions that allow the rings to persist and the moons to follow their orderly orbits. It's a cosmic reminder that even in the apparent emptiness of space, there are invisible forces working constantly to maintain harmony and protect the delicate structures that make our universe so beautiful. The rings of Saturn contain more than just ice and rock particles. Hidden within their shimmering expanse are tiny moonlets, some no larger than a city block, that act as cosmic gardeners. These miniature worlds sweep through the ring material, gathering particles around themselves and creating small clearings in the otherwise dense collections of debris. They work slowly and methodically, like patient sculptors carving delicate patterns into the cosmic medium that surrounds them. These moonlets are too small to be seen from Earth, invisible even to most telescopes, yet their influence shapes the grand architecture of Saturn's rings. They create waves and spirals that ripple outward through the ring particles, generating structures that persist for thousands of years. The waves move with the unhurried pace of geological change, spreading their influence gradually across vast distances in a process that exemplifies the gentle power of persistence over time. Some of these tiny moons orbit within the rings themselves, carving narrow gaps as they travel their circular paths. Others hover just outside the main ring system, using their gravity to keep the ring edges sharp and well-defined. They are the quiet custodians of Saturn's most beautiful feature, working tirelessly to maintain the cosmic artwork that has captivated human imagination for centuries. Saturn's atmosphere contains clouds that form distinct layers, each one floating at a different altitude based on temperature and pressure conditions. These cloud decks create a three-dimensional landscape in the sky, with each layer moving at its own pace and following its own weather patterns. The uppermost clouds are made of ammonia crystals that form delicate, wispy structures resembling terrestrial cirrus clouds, but far more extensive and long-lasting. Deeper in the atmosphere, water clouds form dense layers that rarely see sunlight. These hidden cloud decks exist in perpetual twilight, their droplets condensing and evaporating in cycles that have continued for millions of years. Below them, clouds of exotic compounds create even more mysterious layers, each one contributing to the planet's overall atmospheric symphony. The different cloud layers give Saturn's atmosphere a sense of depth and complexity that becomes more apparent the longer you contemplate it. Like looking into still water and gradually noticing features at different depths, Saturn's atmosphere reveals its layered structure slowly, rewarding patient observation with glimpses of its hidden complexity. The interplay between these layers creates subtle color variations that shift gently across the planet's surface, painting Saturn in soft pastels that seem designed for quiet contemplation. The gravitational influence of Saturn extends far beyond its visible rings, reaching out to guide and protect objects in the distant reaches of its system. This invisible hand gently nudges asteroids and comets, sometimes capturing them as new moons and other times redirecting them on safer paths that carry them away from the inner solar system. Saturn acts as a cosmic shepherd, using its massive gravitational presence to maintain order in its corner of space. This gravitational embrace operates with such subtlety that its effects unfold over millions of years. Small adjustments in orbital paths, barely perceptible changes in trajectory, and gentle captures of passing objects all occur at a pace that makes Saturn seem infinitely patient. The planet appears to consider each gravitational decision carefully, never rushing to alter the delicate balance of forces that keeps its system in harmony. Even objects at the very edge of Saturn's influence feel this gentle guidance. Distant moons in highly elliptical orbits receive periodic gravitational nudges that keep them bound to the system, while allowing them the freedom to wander far from their parent planet. This balance between constraint and liberty creates a sense of cosmic wisdom, as if Saturn understands that the most stable relationships allow for both connection and independence. Saturn's rings cast shadows on the planet's cloud tops, creating patterns that shift slowly as the planet rotates. These ring shadows appear as dark bands that move across Saturn's surface, with the measured pace of a cosmic sundial. During Saturn's equinoxes, which occur roughly every 15 Earth years, the rings cast almost no shadow at all, appearing edge-on and nearly invisible from Earth's perspective. The shadow patterns create a visual rhythm on Saturn's surface that changes throughout the planet's long year. As Saturn orbits the Sun over the course of nearly 30 Earth years, the angle of sunlight striking the rings changes gradually, altering the shadow patterns in ways that would be imperceptible from day to day, but clearly visible over months and years. These moving shadows add another layer of gentle motion to Saturn's already dynamic appearance. They remind us that even something as apparently static as planetary shadows are actually part of a vast, slow dance involving the movements of worlds around their star. The shadows connect Saturn's rings to its atmosphere in a visual way, creating a unified system where every part influences every other part. The space between Saturn's rings, known as the Cassini division, appears empty from a distance, but actually contains its own sparse collection of particles and tiny moonlets. This gap, which spans thousands of kilometers, exists because of gravitational resonances with Saturn's moon Mimas. The resonance creates a zone where ring particles cannot maintain stable orbits, leaving behind what appears to be an empty corridor through the ring system. Within this apparent emptiness, a few hardy particles and small objects do manage to survive, following complex orbital patterns that allow them to avoid the gravitational disturbances that clear out most of the region. These survivors create a tenuous ring of their own, so faint that it can barely be detected even by spacecraft passing nearby. They represent the cosmic equivalent of wildflowers growing in the cracks of a sidewalk, finding ways to thrive in conditions that seem inhospitable to most. The Cassini division serves as a reminder that space is never truly empty, even when it appears so. Like the pause between musical notes that gives them meaning, this gap in Saturn's rings provides contrast that makes the dense ring regions seem even more remarkable. The division creates visual breathing room that allows the eye to rest and appreciate the full scope of Saturn's ring system. Saturn generates more heat than it receives from the Sun, radiating approximately 2.5 times more energy into space than it absorbs from our distant star. This internal heat source comes from the slow gravitational contraction of the planet itself, as Saturn gradually shrinks under its own immense weight. The process releases energy at a steady, gentle rate that has been continuing for billions of years and will continue for billions more. This internal warmth affects Saturn's weather patterns and atmospheric dynamics in subtle but important ways. The heat rising from the planet's interior drives convection currents that help organize the atmospheric bands and contribute to the planet's remarkably stable weather systems. Unlike planets that depend entirely on solar heating, Saturn carries its own internal climate engine that operates independently of external conditions. The steady output of internal heat gives Saturn a sense of self-sufficiency that adds to its peaceful character. The planet doesn't need to depend on the variable energy output of the Sun to maintain its basic atmospheric processes. Instead, it generates its own gentle warmth from within, like a cosmic hearth that has been burning steadily since the early days of the solar system. Saturn's year equals nearly 30 Earth years, creating seasons that last approximately 7.5 years each. This extended seasonal cycle means that changes in lighting and heating patterns unfold with extraordinary slowness, allowing atmospheric and ring features to develop and evolve over timescales that dwarf human experience. A single Saturn spring lasts longer than most human decades. During its long summer, Saturn's northern hemisphere receives more direct sunlight, warming the atmosphere and creating subtle changes in cloud patterns and wind speeds. These seasonal effects are gentle and gradual, building slowly over years rather than manifesting as dramatic shifts. By the time winter arrives in a given hemisphere, the atmospheric adjustments have had years to develop and stabilize. The extended seasons create a sense of cosmic patience that pervades everything about Saturn. Changes that would be rapid and dramatic on Earth unfold with the measured pace of geological processes on Saturn. This temporal stretching transforms normal planetary processes into meditative exercises in the nature of gradual change and long-term stability. The particles in Saturn's rings follow orbital mechanics so precise that they create predictable patterns and structures that persist for thousands of years. Spiral density waves propagate through the rings like ripples in a cosmic pond, carrying information about gravitational disturbances across vast distances at speeds determined by the fundamental physics of orbital motion. These waves create temporary compressions in ring material that appear as spokes or spiral patterns, visible even from Earth-based telescopes. The mathematical beauty of these orbital patterns reflects the underlying harmony of gravitational forces operating on cosmic scales. Each particle follows its own elliptical path around Saturn, yet collectively they create structures that demonstrate the elegant order inherent in celestial mechanics. The rings become a vast analog computer, continuously calculating and displaying the results of gravitational interactions in visual form. Ring particles occasionally collide with each other in gentle encounters that redistribute momentum and energy throughout the system. These collisions are not violent crashes, but rather soft bumps that occur at relative speeds of just a few meters per second. The particles bounce off each other like slow-motion billiard balls, each collision contributing to the overall evolution of ring structure while maintaining the system's fundamental stability. Some of Saturn's smaller moons follow unusual orbital paths that take them far from the planet before bringing them back in long, elliptical journeys that can last several Earth years. These distant wanderers experience dramatic changes in their environment as they travel from the warm inner regions of Saturn's system to the cold outer reaches where sunlight becomes increasingly faint. During their closest approaches to Saturn, these moons experience stronger gravitational forces and warmer temperatures. They speed up in their orbits, following Kepler's laws of planetary motion as they sweep through the inner regions of the system. Then, as they move outward again, they gradually slow down, spending most of their time in the distant, quiet regions where Saturn appears as just a bright star in their sky. These eccentric orbits create a rhythm of approach and departure that gives Saturn's system a breathing quality. The moon's journeys remind us that celestial mechanics can create patterns of motion that mirror natural cycles we recognize from Earth, like the seasonal migrations of animals or the rise and fall of ocean tides. In the vast scale of the Saturn system, these orbital rhythms play out over years rather than days, creating a slow, hypnotic dance that continues endlessly through space. The music of Saturn's magnetosphere creates a cosmic symphony that plays continuously in frequencies beyond human hearing. As charged particles spiral along magnetic field lines, they generate electromagnetic waves that spacecraft can detect and convert into audio signals. These space sounds resemble whale songs or distant wind chimes, creating an ethereal soundtrack to Saturn's orbital dance around the Sun. The magnetosphere essentially turns Saturn into a massive musical instrument, with solar wind serving as the bow and magnetic field lines acting as invisible strings. These electromagnetic melodies change with Saturn's seasons and solar activity, creating variations in the cosmic composition that unfold over months and years. During periods of high solar wind activity, the magnetospheric music becomes more complex and layered, while calmer periods produce simpler, more meditative tones. The entire system responds to these changes with the patience of a master musician, never rushing the tempo but allowing each note to develop naturally. The fact that Saturn generates its own music adds another dimension to the planet's peaceful character. Even in the apparent silence of space, Saturn continues its quiet concert, broadcasting its electromagnetic songs to any listener sensitive enough to receive them. This hidden musical quality transforms our understanding of the planet from a merely visual spectacle to a multi-sensory experience that engages both sight and sound. Saturn's rings contain water ice so pure that it rivals freshly fallen snow on Earth. This cosmic ice has remained frozen for millions of years, preserved in the cold vacuum of space without contamination from atmospheric pollutants or biological processes. Each ring particle is essentially a pristine ice crystal, polished smooth by countless gentle collisions with its neighbors over geological timescales. The purity of this ice gives Saturn's rings their remarkable brightness and reflectivity. When sunlight strikes the ring particles, they sparkle like countless diamonds scattered across the darkness of space. This brilliance is not harsh or glaring, but rather has a soft, diffused quality that seems to glow with inner light. The rings appear almost luminous, as if they generate their own gentle radiance rather than simply reflecting solar illumination. This ancient ice carries within it a record of the early solar system, frozen in time like cosmic amber. The water molecules in Saturn's rings may have originated from primordial comets or the breakup of icy moons, preserving chemical signatures from the dawn of planetary formation. Each particle represents a tiny archive of cosmic history, maintaining its pristine state through billions of years of patient orbiting around the ringed giant. The gravitational relationship between Saturn and its moons creates tidal forces so gentle they operate like cosmic massage therapy. These forces slowly knead the interiors of the larger moons, generating just enough heat to keep subsurface oceans liquid without causing violent geological activity. The process works gradually and steadily, providing consistent warmth that has been maintained for billions of years. Enceladus experiences these tidal flexions as it follows its slightly elliptical orbit around Saturn. The changing gravitational pull stretches and compresses the moon's interior in a rhythm that matches its orbital period. This gentle kneading action prevents the subsurface ocean from freezing solid while avoiding the extreme volcanic activity seen on other tidally heated worlds like Jupiter's Io. The tidal heating process exemplifies Saturn's ability to nurture and sustain complex systems through subtle influences rather than dramatic interventions. The giant planet acts like providing just a cosmic parent enough energy to keep its moons active and interesting while maintaining the stable conditions necessary for long-term evolution. This delicate balance between heating and cooling creates environments that could potentially support life in the hidden oceans beneath icy surfaces. Saturn's rotation creates a subtle flattening effect that makes the planet wider at its equator than from pole to pole. This oblate shape is so pronounced that it can be detected even through small telescopes, giving Saturn a distinctive appearance that sets it apart from more spherical worlds. The flattening occurs because Saturn spins fast enough that centrifugal force partially counteracts gravity at the equator, allowing the planet to bulge outward like a spinning ball of soft clay. This equatorial bulge affects how Saturn's gravity field interacts with its rings and moons, creating subtle variations in orbital mechanics that contribute to the complex dynamics of the entire system. The non-uniform gravity field helps maintain gaps in the rings and influences the orbital evolution of the smaller moons over long periods. These effects unfold so gradually that they're imperceptible on human timescales but become significant over millions of years. Atene, the FLD shape gives Saturn a comfortable, approachable appearance that enhances its peaceful character. Unlike the perfect sphere we might expect from a planet, Saturn's slightly squashed form suggests a world that's relaxed and unhurried, shaped by gentle forces rather than rigid constraints. This subtle departure from geometric perfection makes Saturn seem more organic and natural, a cosmic, like cushion that has settled into its most comfortable configuration. The outer regions of Saturn's ring system contain particles that orbit the planet so slowly they take more than a day to complete one revolution. These distant ring particles experience Saturn's gravity as a gentle pull rather than a commanding force, allowing them to follow leisurely paths that barely seem to curve around the giant planet. Their orbital velocities are so sedate that they move more slowly than a walking pace. These slow-moving particles create the outermost boundaries of Saturn's ring system, forming tenuous structures that fade gradually into the darkness of space. The transition from ring to empty space is not abrupt, but rather occurs over thousands of kilometers, with particle density decreasing so gradually that it's impossible to define exactly where the rings end and interplanetary space begins. The existence of these slow, distant ring particles demonstrates how Saturn's gravitational influence extends far beyond the bright, dense rings visible in most photographs. They represent the planet's ability to maintain gentle control over objects at vast distances, holding onto ring material through the weakest possible gravitational bonds, while still keeping it in stable orbit for millions of years. Saturn's moons show evidence of past geological activity that occurred at a pace so gradual it resembles cosmic meditation. Ancient impact craters on these worlds have been softened and rounded by billions of years of subtle processes, creating landscapes that appear aged and weathered despite existing in the near vacuum of space. The surfaces tell stories of change that unfolded over geological epochs rather than sudden catastrophic events. Tethys, one of Saturn's mid-sized moons, bears a massive impact crater called Odysseus that spans nearly half the moon's diameter. This enormous scar has been softened by eons of gradual settling and ice flow, transforming what must have been a sharp, fresh crater into a gentle depression that barely disturbs the moon's overall spherical shape. The relaxation of this crater represents millions of years of patient geological processes working to restore equilibrium. The gradual healing of impact scars on Saturn's moons reflects the system's overall tendency toward harmony and balance. Rather than preserving the violent signatures of past collisions, these worlds slowly erase the evidence of trauma, returning to peaceful states that emphasize gentle curves and smooth surfaces. This ongoing process of cosmic healing continues today, working imperceptibly to restore serenity to landscapes disturbed by ancient impacts. The composition of Saturn's atmosphere includes trace amounts of exotic compounds that create subtle color variations across the planet's cloud tops. These minor constituents, present in concentrations measured in parts per million, are responsible for the delicate pastels that give Saturn its distinctive appearance. Phosphine creates subtle red tints, while various hydrocarbon compounds contribute yellows and oranges that blend together in soft gradients. These atmospheric colors change slowly with Saturn's seasons as different compounds become more or less prominent in the upper atmosphere. The variations are so gradual that they're barely perceptible from year to year, creating a sense of cosmic patience that matches Saturn's overall character. The planet seems to consider each color change carefully, allowing new hues to develop naturally rather than rushing through dramatic transformations. The subtle beauty of Saturn's atmospheric colors invites contemplation rather than demanding attention. Unlike the bold, contrasting features visible on Jupiter, Saturn's cloud patterns blend together in harmonious combinations that rest the eye rather than exciting it. The planet's appearance suggests a world at peace with itself, where even the atmospheric chemistry operates in gentle equilibrium. Saturn's magnetic field interacts with the solar wind to create a bow shock wave that extends millions of kilometers ahead of the planet. This invisible boundary marks the point where the solar wind first encounters Saturn's magnetic influence, creating a standing wave in the charged particle flow that resembles the wake of a boat moving through water. The bow shock forms a protective barrier that helps shield Saturn's delicate ring system from direct exposure to high-energy particles streaming from the Sun. The shape and position of this bow shock wave change constantly as solar wind conditions vary, but the changes occur smoothly and predictably rather than as sudden jolts or discontinuities. Saturn's magnetosphere responds to solar wind fluctuations like a cosmic shock absorber, gradually adjusting its configuration to accommodate changing external conditions while maintaining overall stability. This dynamic interaction between Saturn's magnetic field and the solar wind creates a complex but orderly system that has been operating continuously for billions of years. The bow shock wave serves as the first line of defense for Saturn's entire system, demonstrating how the planet extends its protective influence far beyond its visible boundaries to create safe conditions for its rings and moons. The orbital resonances between Saturn's moons create mathematical relationships so precise they seem designed by a cosmic clockmaker. Mimas orbits Saturn exactly twice for every single orbit completed by Tethys, while Enceladus maintains a 2-to-1 relationship with Dione. These resonances lock the moons into synchronized patterns that have remained stable for millions of years, creating a celestial clockwork that keeps perfect time. These gravitational relationships prevent the moons from gradually spiraling inward or outward due to tidal interactions with Saturn. Instead, the resonances maintain stable orbital configurations that protect the moons from catastrophic changes while allowing for subtle evolutionary processes to continue over geological time. The system demonstrates how gravitational forces can create self-regulating mechanisms that preserve order across cosmic timescales. The mathematical beauty of these orbital resonances reflects the fundamental harmony underlying celestial mechanics. The moons don't maintain these precise relationships through conscious effort, but rather follow the natural consequences of gravitational physics, creating patterns that would satisfy the most demanding geometric perfectionist. These resonances transform Saturn's moon system into a vast mechanical calculator that continuously computes and displays the elegant solutions to complex gravitational equations. Saturn's rings contain structures called spokes that appear and disappear according to mysterious cycles that scientists are still working to understand. These radial features extend across multiple ring bands like cosmic wheel spokes, forming and dissolving over periods of hours or days. They appear to be composed of fine dust particles that become electrically charged and levitate above the main ring plane, creating temporary structures that glow faintly in scattered sunlight. The formation of ring spokes seems to be connected to Saturn's magnetic field and the planet's rotation period, but the exact mechanisms remain enigmatic. They appear more frequently during certain seasons and tend to be most visible when Saturn's rings are viewed nearly edge-on from Earth. The spokes represent one of Saturn's most mysterious features, demonstrating that even this apparently stable and well-understood system still holds secrets. The transient nature of the ring spokes adds an element of gentle surprise to Saturn's otherwise predictable appearance. Like shadows of clouds passing across a landscape, the spokes provide subtle variations in the ring system's appearance, without disturbing its fundamental structure. They remind us that Saturn continues to reveal new aspects of its character to patient observers, rewarding careful study with glimpses of phenomena that exist at the intersection of electromagnetic physics and orbital mechanics. The temperature variations across Saturn's ring system create zones where different types of ice can exist in stable forms. The innermost rings experience slightly warmer conditions due to their proximity to Saturn's thermal radiation, while the outer rings remain consistently colder than the surface of Pluto. These temperature gradients, though small in absolute terms, are sufficient to influence the physical properties of ring particles across the system. In the warmer inner regions, ring particles may experience occasional sublimation events where surface ice transforms directly into vapor, creating tenuous atmospheres around larger chunks of material. These microscopic weather systems operate on scales invisible to telescopes, but contribute to the ongoing evolution of ring structure over millions of years. The process works so slowly that it resembles geological weathering rather than atmospheric dynamics. The thermal environment of Saturn's rings creates conditions that preserve the ice particles in states similar to permafrost on Earth, but without the seasonal variations that cause freeze-thaw cycles. This stable preservation has maintained the rings' pristine appearance for millions of years, protecting them from the thermal processing that would gradually darken and contaminate ice in more dynamic environments. The rings exist in a state of perpetual winter that keeps them sparkling like fresh snow. The ancient ice within Saturn's rings preserves chemical signatures from the earliest days of our solar system, locked in crystalline structures that have remained unchanged for billions of years. Each particle carries within its molecular arrangement a record of the primordial conditions that existed when the planets were first forming. This frozen archive maintains its pristine state through the gentle preservation of Saturn's cold environment, where temperatures remain so low that chemical processes unfold at imperceptibly slow rates. The ice particles contain trace amounts of rocky material and organic compounds that tell the story of their origins. Some may have formed from the breakup of ancient moons, while others could represent remnants of the original nebular material from which Saturn itself condensed. These microscopic inclusions create subtle variations in particle composition that add depth and complexity to what appears from a distance to be a uniform ring system. Scientists studying samples returned by spacecraft have found that the ice in Saturn's rings is remarkably similar to the purest ice found in Earth's most remote polar regions. This similarity suggests a common origin for water throughout the solar system, connecting Saturn's distant rings to the familiar ice and snow of our own world through an ancient cosmic heritage that spans billions of years and millions of kilometers. The way sunlight interacts with Saturn's ring particles creates optical effects that change throughout the planet's long day and even longer year. When the sun illuminates the rings from different angles, the particles scatter light in ways that reveal hidden structures and create shifting patterns of brightness and shadow. These photometric variations unfold with the measured pace of Saturn's rotation, creating a slow-motion light show that continues perpetually around the planet. During opposition, when Earth lies directly between Saturn and the Sun, the rings appear exceptionally bright due to a phenomenon called the opposition effect. Ring particles backscatter sunlight preferentially, causing the entire ring system to surge in brightness like cosmic snow, reflecting headlights on a winter night. This enhanced illumination reveals details in ring structure that remain hidden during other viewing geometries, rewarding patient observers with periodic glimpses of hidden beauty. The changing angles of sunlight throughout Saturn's year create seasonal variations in ring appearance that unfold over decades. During the planet's equinoxes, when the sun shines directly edge-on through the rings, the normally brilliant structures become almost invisible, reduced to thin lines that barely register against the darkness of space. These dramatic transformations occur so gradually that they require years of patient observation to fully appreciate, making Saturn's ring system a masterpiece of slow-motion celestial theater. Saturn's gravitational field exhibits subtle variations that influence ring particle behavior in ways too small to see but profound in their cumulative effects. Tiny asymmetries in the planet's mass distribution create gentle nudges that guide particle motions over millions of years, slowly sculpting ring structure through the patient application of almost imperceptible forces. These gravitational whispers work like cosmic erosion, gradually carving patterns into the ring system that persist for geological ages. The planet's internal structure contributes to these field variations through the slow convection of material in Saturn's deep interior. As warmer material rises and cooler material sinks within the planet, slight changes in mass distribution create corresponding adjustments in the gravitational field that propagates outward through the ring system. These internal rhythms operate on timescales so extended that they represent some of the slowest processes occurring anywhere in the solar system. Even Saturn's rapid rotation contributes to the gravitational complexity by creating a slightly flattened field that varies with latitude. Ring particles at different distances from Saturn's equatorial plane experience subtly different gravitational environments, leading to vertical oscillations that add three-dimensional complexity to what appears to be a flat ring system. These gentle undulations create a kind of cosmic topography that exists primarily in the motions of particles rather than in any solid landscape. The study of Saturn's ring dynamics has revealed fundamental principles of celestial mechanics that apply throughout the universe. The same gravitational processes that shape Saturn's rings also operate in galaxy formation, asteroid belt evolution, and the accretion disks around forming stars. Saturn's rings serve as a nearby laboratory where scientists can observe these universal processes in exquisite detail, providing insights into how matter organizes itself under the influence of gravity across cosmic scales. The mathematical equations that describe ring particle motion are remarkably similar to those used to model the behavior of gas molecules in statistical mechanics. Both systems involve large numbers of individual units following simple physical laws that collectively produce complex emergent behaviors. This similarity allows researchers to apply techniques from diverse fields of physics to better understand how Saturn's rings maintain their structure over such vast periods of time. The precision required to model ring dynamics has pushed the development of computational techniques that now find applications in fields far removed from planetary science. The algorithms developed to track millions of ring particles have been adapted for use in weather prediction, financial modeling, and even the design of traffic flow systems. Saturn's rings continue to inspire advances in human understanding that extend far beyond their immediate cosmic neighborhood. Saturn, thick that an atmosphere so's largest moon, Titan, maintains found it creates a greenhouse to that effect, similar with dramatic lead of creating hellish surface different results. Instead, on Venus, though conditions, Titan's atmospheric just warm enough to blanket maintains temperature's water cycle, in remarkable that mirrors Earth support a complex methane cycle with the same fundamental principles as Terrace detail. This alien weather system operates Ryle meteorology, but uses completely different chemical compounds to create familiar patterns of evaporation, cloud formation, and precipitation. The atmospheric pressure on Titan's surface is about 50% higher than Earth's sea level pressure, creating conditions where a human could walk around wearing only a breathing apparatus and warm clothing. This benign pressure environment, combined with the moon's low gravity, would make movement on Titan's surface feel uniquely pleasant and effortless. The thick atmosphere would provide protection from radiation while creating acoustic conditions where voices would sound deeper and more resonant than on Earth. Titan's weather patterns unfold with the leisurely pace appropriate to Saturn's extended seasonal cycle. Storm systems develop slowly and persist for months, creating cloud formations that dwarf terrestrial weather in both scale and duration. The methane precipitation that falls as rain and snow accumulates in vast lakes and seas that remain stable for decades, creating permanent geographical features that change only gradually as seasons progress over the course of years. The interaction between Saturn's magnetosphere and the solar wind creates particle populations that spiral along magnetic field lines in complex patterns resembling vast cosmic tornadoes. These magnetospheric dynamics generate aurora displays at Saturn's poles that are more subtle and persistent than their terrestrial counterparts, creating curtains of light that dance continuously in the planet's upper atmosphere. The auroras appear as gentle glows rather than dramatic flashes, maintaining their ethereal beauty for hours at a time. These auroral displays respond to changes in solar wind conditions with the measured pace characteristic of Saturn's entire system. Rather than flickering rapidly like Earth's northern lights, Saturn's auroras evolve slowly, brightening and dimming over periods of minutes or hours as magnetic field conditions adjust to new equilibrium states. The colors tend toward subtle blues and greens that blend harmoniously with Saturn's overall pastel appearance. The magnetic field lines that guide these auroral particles extend far into space, connecting Saturn's polar regions to the distant boundaries of its magnetosphere. This invisible network creates electromagnetic pathways that allow energy and information to flow between different regions of Saturn's space environment, maintaining communication channels that help coordinate the behavior of the entire magnetic system across millions of cubic kilometers of space. Saturn's moon Iapetus displays one of the most striking examples of geological patience in the solar system. This distant world shows a stark contrast between its dark leading hemisphere and bright trailing hemisphere, creating an appearance that resembles a cosmic yin-yang symbol. This dramatic color difference developed over billions of years as the moon slowly accumulated dark material on its forward-facing surface, while its trailing hemisphere remained pristine and bright. The process that created Iapetus's two-toned appearance operates through thermal runoff effects that work almost imperceptibly slowly. Dark material absorbs more sunlight and becomes slightly warmer, causing nearby ice to sublimate and migrate toward cooler or brighter regions. This gradual redistribution of surface material has been continuing for billions of years, creating an increasingly sharp boundary between light and dark regions that demonstrates how patient processes can create dramatic results given sufficient time. Iapetus also features a mysterious littoral ridge that extends around EQ'd nearly half the moon's circumference like a cosmic seam. This mountain range reaches heights of 20 kilometers in some places, creating a landscape that would be spectacular if viewed from the surface. The origin of this ridge remains enigmatic, but its existence adds to Iapetus's character as one of the most visually distinctive worlds in the outer solar system, shaped by processes that operated on timescales that dwarf human civilization. The orbital mechanics of Saturn's system create gravitational focusing effects that concentrate interplanetary dust into specific regions around the planet. These dust accumulations form tenuous rings that are too faint to see with ordinary telescopes, but can be detected by sensitive instruments aboard spacecraft. The dust particles follow complex trajectories that bring them into temporary gravitational resonances with Saturn's moons, creating structures that persist for thousands of years before slowly dispersing. These invisible dust rings demonstrate how Saturn's gravitational influence extends throughout the solar system, capturing material from distant sources and incorporating it into the planet's extended family of orbiting objects. Dust grains knocked off the surfaces of distant moons or liberated from passing comets can find their way into stable orbits around Saturn, where they remain for geological ages as nearly invisible components of the planet's ring system. The study of these faint dust rings has revealed the complex ways in which different components of Saturn's system interact over long periods. Moons, rings, magnetosphere, and interplanetary environment all influence each other through subtle mechanisms that operate continuously but imperceptibly, creating a dynamic equilibrium that maintains overall stability while allowing for gradual evolutionary changes that unfold over millions of years. Saturn's internal heat generation creates convection patterns that may influence the planet's magnetic field in ways that are still being studied and understood. The slow circulation of material within Saturn's interior operates on timescales measured in millions of years, creating gradual changes in the planet's magnetic environment that could affect everything from ring particle behavior to auroral activity. These deep internal processes represent some of the most patient and persistent phenomena in the entire solar system. The convective motions within Saturn transport heat from the planet's core to its surface through mechanisms that operate much more slowly than similar processes on smaller, rockier worlds. The immense scale and low density of Saturn's interior create conditions where convection cells can persist for geological ages, maintaining stable patterns of heat transport that contribute to the planet's remarkably steady energy output. These internal dynamics may also influence Saturn's atmospheric circulation patterns through subtle couplings between the planet's interior and its visible cloud layers. The relationship between deep convection and surface weather represents one of the most complex aspects of Saturn's behavior, involving interactions between processes that operate on vastly different timescales and spatial scales, yet somehow maintain coherent patterns that persist for millions of years. The gentle dance of Saturn's weather systems operates according to principles that seem almost designed to promote tranquility. Unlike the chaotic storms that rage across other gas giants, Saturn's atmospheric disturbances follow predictable patterns that unfold with remarkable serenity. Wind speeds, while substantial by terrestrial standards, maintain steady velocities that rarely fluctuate dramatically, creating atmospheric rivers that flow with the consistency of cosmic clockwork. These wind patterns organize themselves into distinct bands that circle the planet like invisible highways, each maintaining its own speed and direction with minimal interference from neighboring streams. The boundaries between these atmospheric zones remain surprisingly stable, creating long-term weather patterns that can persist for decades without significant disruption. This atmospheric organization reflects Saturn's overall tendency toward order and harmony, even in systems that might be expected to show chaotic behavior. The chemical processes that drive Saturn's weather operate at temperatures and pressures that slow molecular interactions to a gentle pace. Reactions that might be violent or rapid under Earth-like conditions proceed with measured deliberation in Saturn's frigid environment, contributing to the planet's overall aura of cosmic patience. Even the formation and dissipation of cloud systems follows extended timelines that allow each meteorological event to develop fully before giving way to the next phase. Saturn's gravitational influence creates tidal effects throughout its moon system that operate like a vast, slow-motion symphony of celestial forces. These tidal interactions work so gradually that they represent some of the most patient sculptors in the cosmos, reshaping lunar surfaces and internal structures over periods that span millions of years. The process demonstrates how even the gentlest forces, when applied consistently over sufficient time, can create profound transformations in cosmic architecture. The tidal heating experienced by Saturn's moons occurs through mechanisms so subtle that they barely register as changes from day to day. Yet their cumulative effects over geological time have created some of the most intriguing environments in the solar system. The gentle flexing and kneading of lunar interiors proceeds with the rhythm of planetary breathing, creating warmth through friction in a process that exemplifies the power of persistence over intensity. These tidal relationships also create orbital evolution patterns that unfold over timescales, so extended they require computer models to fully appreciate. Moons gradually spiral inward or outward in their orbits, following trajectories determined by the delicate balance between gravitational forces and tidal dissipation, creating a cosmic ballet where the choreography extends across millions of years and the dancers are entire worlds. The composition of Saturn's ring particles reveals a history of gentle collisional evolution that has been proceeding for millions of years without catastrophic disruption. Rather than experiencing violent shattering events, ring particles undergo countless soft encounters that gradually redistribute mass and momentum throughout the system. These collisions occur at velocities so low that they resemble cosmic bumper cars rather than destructive impacts, allowing the ring system to maintain its delicate structure while continuing to evolve slowly over time. The size distribution of ring particles follows mathematical patterns that reflect this gentle evolutionary process, with larger chunks gradually breaking down into smaller fragments through patient erosion rather than sudden fragmentation. This size evolution creates a particle population that spans many orders of magnitude, from dust grains smaller than snowflakes to house-sized boulders, all coexisting in the same orbital space without disrupting each other's peaceful circuits around Saturn. The surfaces of ring particles show evidence of continuous polishing through countless gentle collisions, creating ice fragments with smooth, rounded edges that reflect sunlight with exceptional efficiency. This ongoing surface processing has been removing irregularities and sharp edges for millions of years, transforming what might once have been jagged debris into the polished gemstones that give Saturn's rings their remarkable brilliance and beauty. Saturn's magnetic field exhibits a unique property among planetary magnetospheres. It appears to be almost perfectly aligned with the planet's rotational axis. This unusual symmetry creates magnetic field lines that follow exceptionally orderly patterns, lacking the complex tilts and offsets seen in most other planetary magnetic systems. The result is a magnetosphere that operates with geometric precision, creating particle trajectories that follow elegant mathematical curves through space. This magnetic symmetry contributes to the overall sense of order and harmony that characterizes Saturn's entire system. Charged particles spiral along field lines that trace perfect helical paths, creating patterns of motion that would satisfy the most demanding geometric perfectionist. The magnetic field serves as an invisible scaffolding that organizes the space environment around Saturn according to principles of mathematical beauty. The interaction between this symmetrical magnetic field and Saturn's ring system creates electromagnetic effects that help maintain ring stability over long periods. Charged dust particles within the rings respond to magnetic forces in ways that can prevent them from spiraling into Saturn's atmosphere, while also protecting them from disruption by external magnetic disturbances. The magnetic field acts as both shepherd and protector for the ring particles, maintaining their orbital integrity through gentle electromagnetic guidance. The seasonal variations in Saturn's appearance occur with such gradual progression that they require years of patient observation to fully appreciate. As Saturn moves through its 30-year orbit around the Sun, the changing angle of solar illumination slowly reveals different aspects of the ring system and creates subtle shifts in atmospheric coloration. These transformations unfold with the measured pace of geological change, rewarding dedicated observers with glimpses of rarely seen configurations. During Saturn's northern summer, which lasts approximately 7.5 Earth years, the ring system appears tilted toward Earth in configurations that maximize the visibility of ring structure and create dramatic shadow patterns on the planet's cloud tops. The gradual progression toward this optimal viewing geometry takes place over several years, allowing astronomers to anticipate and prepare for periods of enhanced ring visibility that occur only once per Saturn generation. The transition between seasons creates particularly beautiful moments when Saturn's rings appear edge-on to Earth, reducing them to thin lines that seem to disappear entirely when viewed through small telescopes. These ring plane crossings occur twice during each Saturnian year and represent moments of cosmic minimalism when the planet's most famous feature becomes nearly invisible, temporarily transforming Saturn into an apparently ordinary gas giant before gradually revealing its ringed glory once again. The thermal properties of Saturn's atmosphere create temperature gradients that drive convection patterns extending from the planet's visible cloud tops deep into its interior. These vertical motions operate on scales that dwarf terrestrial weather systems, with individual convection cells spanning thousands of kilometers and persisting for decades or centuries. The gentle circulation patterns transport heat and chemical compounds throughout Saturn's atmosphere with the efficiency of a planet-sized heat engine. The stability of these atmospheric circulation patterns contributes to Saturn's remarkably consistent appearance over time. Unlike Jupiter, which displays dramatic changes in its cloud patterns from year to year, Saturn maintains atmospheric features that can persist for decades without significant alteration. This consistency reflects the planet's overall character as a world where change occurs gradually and predictably, rather than through sudden dramatic events. The chemical composition of Saturn's atmosphere includes trace amounts of compounds that create subtle spectral signatures, detectable only through careful analysis of reflected sunlight. These minor constituents, present in concentrations too small to affect the planet's overall appearance, tell stories about Saturn's formation and evolution that extend back to the earliest days of the solar system. Each spectral line represents a chapter in the planet's history, preserved in its atmospheric chemistry like pages in a cosmic library. Saturn's moon Rhea displays surface features that demonstrate how impact cratering can create landscapes of surprising tranquility, even in environments subjected to billions of years of bombardment. The ancient craters covering Rhea's surface have been softened by eons of subtle geological processes, creating a terrain that appears aged and weathered despite the moon's location in the near vacuum of space. The impact scars tell stories of violent events from the past, while simultaneously demonstrating nature's ability to heal and restore serenity over time. The distribution of craters across Rhea's surface follows patterns that reflect the changing impact environment in Saturn's neighborhood over billions of years. Older regions show the heavy, cratering characteristic of the early solar system, when debris from planetary formation created hazardous conditions throughout the outer planets. Younger areas display fewer impacts, indicating that the Saturn system has gradually become a more peaceful place, as most of the dangerous debris was either swept up by the planets or ejected into interstellar space. Rhea's geological history demonstrates how even the most violent cosmic processes eventually give way to periods of quiet stability. The moon's surface preserves evidence of an active past while presenting a contemporary appearance of serene acceptance. Having absorbed the scars of ancient bombardment into a landscape that now radiates patience and endurance. The craters serve as reminders that peace often emerges from periods of chaos, given sufficient time for healing. The way Saturn's rings interact with electromagnetic radiation creates subtle effects that vary depending on the wavelength of light used to observe them. In visible light, the rings appear as brilliant white structures with subtle color variations, while infrared observations reveal temperature differences that map the thermal properties of ring particles. Radio waves can penetrate the rings and reveal structural details invisible to optical telescopes, creating a multi-spectral portrait that shows different aspects of ring architecture. These wavelength-dependent properties allow scientists to study ring composition and structure using techniques that extract information from every part of the electromagnetic spectrum. Each wavelength reveals different secrets about the rings, from the chemical composition of particles to their size distribution and thermal properties. The rings serve as a natural laboratory where researchers can test theories about how light interacts with collections of small particles under conditions impossible to replicate on Earth. The spectral properties of Saturn's rings also change subtly over time as particles undergo gradual surface modification through exposure to charged particles and solar radiation. These evolutionary processes work so slowly that they require decades of careful observation to detect, creating long-term studies that span multiple generations of researchers. The rings continue to reveal new secrets to patient investigators willing to commit years or decades to understanding their complex behavior. Saturn's gravitational field creates subtle perturbations in the orbits of its innermost moons that demonstrate how even tiny forces can have profound effects when applied over sufficient time. These orbital modifications occur so gradually that they're barely detectable from year to year, yet their cumulative effects over millions of years can completely reshape the architecture of the moon system. The process exemplifies how cosmic evolution often proceeds through patient accumulation of almost imperceptible changes rather than dramatic sudden events. The mathematical precision required to detect these subtle orbital changes pushes the limits of astronomical measurement techniques, requiring observations accurate to fractions of arcseconds maintained over decades of consistent monitoring. The dedication required for such long-term studies reflects the same patience exhibited by the cosmic processes being investigated, creating a harmony between human scientific endeavor and natural phenomena. These orbital perturbations also create resonance relationships between moons that can persist for millions of years, while slowly evolving in response to tidal effects and other subtle influences. The resonances act as cosmic memory devices that preserve information about past interactions and predict future evolutionary pathways, creating a dynamic system that maintains stability while allowing for gradual change over geological timescales. The space environment around Saturn contains populations of charged particles that create a complex ecosystem of electromagnetic interactions extending throughout the magnetosphere. These particle populations include ions and electrons captured from the solar wind, material sputtered from moon surfaces, and charged dust from the ring system, all following trajectories determined by the intricate structure of Saturn's magnetic field. The result is a three-dimensional plasma environment that fills the space around Saturn with invisible rivers of charged particles flowing along magnetic field lines. The interaction between these particle populations and Saturn's moons creates a subtle form of space weather that affects everything from surface chemistry to atmospheric dynamics. Charged particles striking moon surfaces can alter their composition over millions of years, while electromagnetic effects can influence the behavior of any atmospheres present around the larger moons. These processes work so gradually that they represent some of the most patient forms of cosmic erosion, reshaping entire worlds through the accumulated effects of countless microscopic interactions. The study of Saturn's magnetospheric environment has revealed principles of plasma physics that apply throughout the universe, from the space around other planets to the environments of distant stars and galaxies. Saturn's magnetosphere serves as an accessible laboratory where researchers can investigate fundamental processes that operate on scales ranging from microscopic particle interactions to cosmic phenomena involving entire stellar systems. As we drift through these gentle revelations about Saturn's cosmic neighborhood, each detail adds another layer to our understanding of this remarkable world. The planet emerges not just as a beautiful object in the night sky, but as a complex system where countless processes work together with patient harmony to create and maintain one of the universe's most serene and captivating displays. Every aspect of Saturn, from its rapid rotation to its distant moons, contributes to a cosmic symphony that has been playing for billions of years and will continue long after human civilization has become part of the same cosmic dust that sparkles in Saturn's rings. The mathematical relationships governing Saturn's system reveal an underlying order that speaks to fundamental principles operating throughout the universe. These are not arbitrary arrangements, but rather the natural consequences of physical laws working out their implications over vast spans of time. In studying Saturn, we glimpse the patient artistry of physics itself, creating beauty through the simple application of gravity, electromagnetism, and thermodynamics across scales that challenge human comprehension. The delicate balance of forces operating throughout Saturn's domain creates conditions so stable that the system has maintained its essential character for billions of years, while allowing for gradual refinements that enhance its beauty over time. This cosmic stability emerges not from rigid constraints, but from the flexible interplay of gravitational influences that adjust automatically to changing conditions, creating a self-regulating system that demonstrates nature's ability to maintain harmony through dynamic equilibrium rather than static perfection. The ring particles that seem so permanent and unchanging actually participate in a continuous process of gentle redistribution, with material slowly migrating between different orbital zones over periods measured in millions of years. This patient circulation ensures that no single region of the ring system becomes depleted or overcrowded, maintaining the balanced particle distribution that gives Saturn's rings their uniform brightness and structural integrity across their vast expanse. Individual ring particles follow orbital paths that bring them into periodic alignments with their neighbors, creating temporary configurations that enhance the system's overall gravitational stability. These alignments occur with the precision of celestial clockwork, demonstrating how seemingly random collections of objects can spontaneously organize themselves into patterns that persist far longer than any individual component's orbital period. Saturn's atmospheric dynamics create weather patterns that operate on timescales so extended they transform meteorology into geology. Storm systems that would dissipate within days or weeks on Earth can maintain their structure for months or years in Saturn's stable environment, allowing atmospheric features to develop complexity and character that would be impossible in more chaotic conditions. These long-lived weather patterns contribute to Saturn's overall sense of cosmic patience, where even violent storms unfold with measured deliberation. The chemical reactions occurring within Saturn's atmosphere proceed at rates determined by the planet's frigid temperatures, creating a natural laboratory where molecular interactions can be studied in slow motion. Compounds that would react explosively under terrestrial conditions combine gently in Saturn's environment, forming complex molecules through processes that extend over decades or centuries rather than seconds or minutes. These atmospheric chemistry processes contribute to the subtle color variations that paint Saturn's cloud tops in soft pastels that shift almost imperceptibly over the course of the planet's long seasons. The gradual evolution of atmospheric hues creates a kind of cosmic time-lapse photography that reveals the planet's chemical personality through gentle changes in its visual appearance. The thermal structure of Saturn's interior creates convection patterns that transport energy from the planet's core to its surface through mechanisms that operate with geological patience. The scale of these internal circulation systems dwarfs anything experienced on Earth, with individual convection cells large enough to encompass entire terrestrial continents, yet moving so slowly that their effects accumulate over millions of years. This internal heat transport system contributes to Saturn's remarkably consistent energy output, providing a steady flow of warmth that has been maintained at nearly constant levels throughout the planet's observable history. The reliability of this internal heating helps stabilize Saturn's atmospheric dynamics and contributes to the predictable behavior that characterizes the entire system. The relationship between Saturn's internal structure and its magnetic field generation involves processes that operate on timescales extending far beyond human experience, creating a planetary dynamo that has been operating continuously for billions of years. The magnetic field serves multiple functions simultaneously, protecting the ring system from external disturbances while organizing the space environment according to electromagnetic principles that create order from apparent chaos. Saturn's moon. Dione presents surface features that tell stories of geological processes operating under conditions unlike anything found on terrestrial worlds. The moon's icy composition allows for forms of tectonics that work through mechanisms unique to frozen environments, creating landscape features that demonstrate how familiar geological principles can produce unfamiliar results when operating under different physical conditions. The wispy terrain covering parts of Dion's surface may represent evidence of ancient geological activity that occurred through mechanisms involving the sublimation and redeposition of surface ice over millions of years. These features suggest that even apparently inactive worlds can undergo gradual landscape evolution through processes so subtle they barely qualify as geological activity by terrestrial standards. Dion's orbital relationship with Saturn creates tidal effects that may continue to influence the moon's internal structure, maintaining geological processes that operate at rates almost too slow to detect, but persistent enough to reshape the world over cosmic timescales. The moon serves as an example of how tidal heating can create geological activity that persists long after more obvious forms of planetary evolution have ceased. The electromagnetic environment surrounding Saturn creates conditions that influence everything from ring particle behavior to the evolution of moon atmospheres through mechanisms that operate continuously but almost imperceptibly. Charged particles spiraling along magnetic field lines carry energy and momentum throughout Saturn's magnetosphere, creating invisible currents that help maintain the system's overall stability while contributing to gradual evolutionary changes. These electromagnetic effects work in concert with gravitational forces to create a multi-layered system of influences that shape every aspect of Saturn's environment. The interaction between different types of forces demonstrates how complex systems can emerge from the interplay of simple physical principles, creating emergent behaviors that transcend the properties of individual components. The study of Saturn's electromagnetic environment has revealed phenomena that exist nowhere else in the solar system, including unique forms of plasma behavior that arise from the specific combination of magnetic field strength, particle populations, and geometric configurations found only in Saturn's neighborhood. These discoveries continue to expand our understanding of how electromagnetic forces operate in space environments. Saturn's ring system contains gravitational resonances so precisely tuned that they create gaps and enhancements in ring structure that have remained stable for millions of years, despite the chaotic nature of multi-body gravitational interactions. These resonances demonstrate how mathematical relationships can emerge naturally from physical processes, creating patterns that would satisfy the most demanding geometric perfectionist, while arising spontaneously from the simple application of Newton's laws. The maintenance of these resonance relationships requires a delicate balance between different gravitational influences that must be preserved over vast periods of time. The stability of Saturn's resonance network testifies to the fundamental reliability of gravitational mechanics operating on cosmic scales, creating mathematical poetry written in the language of orbital dynamics. Each resonance gap in Saturn's rings represents a zone where specific orbital periods cannot be maintained due to gravitational interference from Saturn's moons. These forbidden zones create natural boundaries that organize ring to principles that reflect structure, according the underlying mathematical harmony of celestial mechanics, transforming Saturn's rings into a vast analog computer that continuously calculates and displays the solutions to complex gravitational equations. The seasonal illumination changes that affect Saturn's ring system create photometric variations that unfold with such gradual progression, they require decades of patient observation to fully document. As Saturn moves through its orbit around the Sun, the changing angle of solar illumination slowly reveals different aspects of ring architecture, while creating shifting patterns of brightness and shadow that transform the system's appearance in subtle but profound ways. These illumination changes affect not only the visual appearance of the rings, but also their thermal properties, creating temperature variations that influence particle behavior and ring dynamics over seasonal timescales. The rings respond to these thermal cycles with adjustments in structure and particle distribution that occur too slowly to observe directly, but can be detected through careful long-term monitoring programs. The interaction between seasonal illumination changes and ring particle properties creates feedback mechanisms that help maintain ring stability over periods much longer than Saturn's orbital period. These self-regulating processes demonstrate how systems can develop internal mechanisms that preserve their essential characteristics, while allowing for adaptive responses to changing external conditions. Saturn's gravitational influence extends far beyond its visible ring system, reaching out to capture and organize material from throughout the outer solar system. Dust particles knocked free from distant moons or liberated from passing comets can find their way into stable orbits around Saturn, where they contribute to faint ring structures that exist at the very limits of detectability. These extended dust rings demonstrate how Saturn's gravitational reach creates a zone of influence that encompasses a volume of space many times larger than the planet itself. Within this gravitational domain, Saturn acts as a cosmic collector, gathering material from diverse sources and incorporating it into an extended family of orbiting objects. That includes everything from house-sized ring particles to microscopic dust grains. The process of capturing and organizing this diverse material occurs through mechanisms that work over time, scale spanning millions of years, creating a constantly evolving system that maintains overall stability while continuously incorporating new components. This ongoing accretion process may have been operating since Saturn's formation, gradually building the complex ring system we observe today through the patient accumulation of cosmic debris. The thermal properties of Saturn's ring particles create temperature distributions that vary not only with distance from Saturn, but also with particle size, composition, and local particle density. These temperature variations influence everything from particle sublimation rates to collision dynamics, creating feedback mechanisms that help regulate ring structure and evolution over long periods. Larger ring particles maintain different thermal properties than smaller ones due to their greater thermal inertia and different surface-to-volume ratios. This size-dependent thermal behavior creates conditions where particles of different sizes can coexist in the same orbital zones while experiencing subtly different environmental conditions that influence their long-term evolution. The thermal environment within Saturn's rings also affects the behavior of any gases or vapors that may be present in the ring system, creating tenuous atmospheric conditions that exist only in the immediate vicinity of ring particles. These microscopic atmospheres participate in chemical and physical processes that contribute to the ongoing evolution of ring composition over geological timescales. Saturn's moon Mimas, despite its small size, plays a crucial role in maintaining the structure of Saturn's ring system through gravitational resonances that create some of the most prominent features visible in the rings. The famous Cassini division, which appears as a dark gap separating Saturn's A and B rings, exists primarily because particles in that region experience gravitational perturbations from Mimas that prevent stable orbits from forming. This gravitational influence operates through mechanisms that demonstrate how small objects can have effects far out of proportion to their size when they occupy strategic positions within complex dynamical systems. Mimas serves as a cosmic shepherd, using its gravity to organize ring structure according to mathematical principles that create order from what would otherwise be chaotic particle distributions. The relationship between Mimas and Saturn's rings illustrates how gravitational resonances can act as cosmic memory devices, preserving information about past orbital configurations while influencing future evolutionary pathways. These resonance relationships create a form of gravitational inheritance that passes dynamical information from one generation of ring particles to the next across millions of years. The surface composition of Saturn's icy moons reveals chemical signatures that preserve records of the early solar system's chemical environment, locked in frozen deposits that have remained largely unchanged for billions of years. These chemical archives contain information about the distribution of elements and compounds during planetary formation, providing glimpses into conditions that existed when Saturn's system was first taking shape. The preservation of these chemical records depends on the stable, cold conditions that have characterized Saturn's neighborhood throughout most of solar system history. Unlike the inner planets, where geological activity and atmospheric processes have erased most evidence of primordial conditions, Saturn's moons maintain frozen libraries of information about cosmic chemistry, dating back to the earliest epochs of planetary formation. Analysis of these chemical signatures has revealed unexpected complexity in the processes that distributed materials throughout the early solar system, suggesting that the formation of planetary systems involves more intricate chemical sorting mechanisms than previously understood. Saturn's moons serve as witnesses to these ancient processes, preserving evidence that continues to inform our understanding of how planetary systems develop. The electromagnetic properties of Saturn's rings create interactions with the planet's magnetic field that generate radio emissions detectable by sensitive receivers on Earth and throughout the solar system. These radio signals carry information about ring structure, particle composition, and electromagnetic conditions within Saturn's magnetosphere, creating a form of cosmic broadcasting that has been transmitting continuously for millions of years. The characteristics of these radio emissions change in response to variations in solar wind conditions, ring particle distribution, and magnetic field strength, creating a complex signal that encodes information about multiple aspects of Saturn's environment. Scientists have learned to decode these radio messages, extracting data about conditions in regions of Saturn's system that cannot be observed directly through conventional telescopic techniques. The radio emissions from Saturn's rings represent one of the most subtle forms of communication occurring in the solar system, broadcasting information about the planet's electromagnetic environment to any receiver sensitive enough to detect and interpret the signals. This cosmic radio station operates on frequencies and power levels that require sophisticated equipment to monitor, but rewards careful listeners with detailed information about one of nature's most elegant electromagnetic phenomena. The gravitational interactions between Saturn's rings and moons create tidal effects that propagate through both systems, influencing everything from ring particle orbits to moon surface features through mechanisms that operate with the patience of geological processes. These tidal influences work both ways, with rings affecting moon behavior and moons influencing ring structure through gravitational connections that span thousands of kilometers of space. The strength of these tidal effects varies with orbital configuration, creating cyclic variations in gravitational stress that unfold over periods ranging from hours to years, depending on the specific objects involved. These gravitational rhythms contribute to the overall sense of cosmic clockwork that characterizes Saturn's system, where every component participates in multiple overlapping cycles of gravitational influence. So, the cumulative effects of these tidal interactions shape the long-term evolution of Saturn's entire system, creating evolutionary pathways that extend millions of years into the future while preserving evidence of past gravitational relationships in the current orbital architecture. The system serves as a gravitational computer that continuously calculates and implements the solutions to complex multi-body problems through the patient application of physical forces. Saturn's atmospheric circulation patterns create jet streams that maintain consistent velocities and directions over periods measured in decades, demonstrating a level of meteorological stability that has no equivalent in terrestrial weather systems. These atmospheric rivers flow with the persistence of ocean currents, carrying energy and chemical compounds around the planet in patterns that have remained essentially unchanged throughout the history of human observation. So, the maintenance of these stable circulation patterns depends on the planet's internal heat source, which provides consistent energy input that drives atmospheric motions without the seasonal variations that create chaotic weather patterns on other worlds. This steady energy supply creates conditions where atmospheric dynamics can develop long-term patterns that persist far longer than individual weather events. The chemical composition of Saturn's atmosphere varies subtly with altitude and latitude, creating a three-dimensional structure that influences circulation patterns and contributes to the planet's overall atmospheric stability. These compositional variations develop through processes that operate over thousands of years, creating chemical gradients that help maintain the organized flow patterns that give Saturn's atmosphere its remarkably consistent appearance. The way Saturn's rings scatter sunlight creates optical phenomena that vary depending on the viewing geometry, revealing different aspects of ring structure and composition as the planet moves through its orbit around the Sun. These photometric effects include opposition surges, where the rings appear exceptionally bright when viewed directly opposite the Sun, and phase angle variations that reveal information about particle size distribution and surface properties. The study of these optical effects has provided insights into the physical properties of ring particles that would be impossible to obtain through direct sampling, demonstrating how careful analysis of scattered light can reveal detailed information about remote objects. Saturn's rings serve as a natural laboratory for testing theories about how light interacts with collections of small particles under conditions that cannot be replicated in terrestrial laboratories. The seasonal variations in ring illumination create opportunities to observe optical phenomena that occur only during specific geometric configurations, requiring decades of patient observation to document fully. These rare viewing opportunities provide glimpses of ring properties that remain hidden during most observational circumstances, rewarding dedicated observers with insights that emerge only through long-term monitoring programs. The magnetic field of Saturn creates charged particle populations that follow complex trajectories through the planet's magnetosphere, creating invisible rivers of plasma that flow along magnetic field lines in patterns determined by electromagnetic principles. These particle streams carry energy and momentum throughout Saturn's space environment, contributing to phenomena ranging from auroral displays to ring particle behavior through mechanisms that operate continuously but almost imperceptibly. The behavior of these charged particle populations changes in response to variations in solar wind conditions, creating a dynamic, magnetospheric environment that adjusts constantly to changing external influences while maintaining overall stability. These adjustments occur through processes that demonstrate the magnetosphere's ability to absorb and redistribute energy from external sources without losing its fundamental structure. The interaction between Saturn's magnetic field and its ring system creates electromagnetic effects that may contribute to ring stability by helping to confine charged dust particles and preventing them from spiraling into Saturn's atmosphere. These electromagnetic influences work in concert with gravitational forces to maintain ring structure through mechanisms that involve both particle mechanics and plasma physics. Saturn's moon system includes objects that follow such distant orbits. They spend most of their time in the cold outer reaches, where Saturn appears as little more than a bright star in their sky. These distant moons experience dramatic changes in their environment as they follow highly elliptical paths that bring them close to Saturn before carrying them back out to the edge of the planet's gravitational influence. The extreme orbital variations experienced by these distant moons create conditions that would challenge any potential life forms, with environmental changes far more dramatic than anything experienced on planets with circular orbits. The moons serve as natural experiments in extreme orbital mechanics, demonstrating how gravitational systems can maintain stability even under conditions that seem to push the limits of what should be possible. The study of these distant moons has revealed information about the extent of Saturn's gravitational influence and the mechanisms that allow planetary systems to capture and retain objects from the surrounding interplanetary environment. These moons may represent captured asteroids or comet nuclei that found their way into Saturn's gravitational embrace through chance encounters that occurred millions of years ago. The thermal evolution of Saturn's interior continues today through processes that operate so slowly they represent some of the most patient phenomena in the solar system. The gradual contraction of the planet under its own gravity releases energy at a rate that has remained nearly constant for billions of years, providing the internal heat source that drives atmospheric circulation and contributes to the planet's overall energy budget. This slow gravitational contraction occurs through mechanisms that compress Saturn's interior by amounts too small to detect directly, yet the cumulative effects over millions of years are sufficient to power the planet's atmospheric dynamics and contribute to its magnetic field generation. The process demonstrates how astronomical objects can maintain active energy production through mechanisms that require no external fuel source. The study of Saturn's thermal evolution provides insights into the long-term behavior of giant planets and helps scientists understand how these massive worlds maintain their activity over billions of years. Saturn serves as an example of how planetary systems can achieve remarkable longevity through the patient application of fundamental physical processes that operate with the reliability of cosmic clockwork. As we continue our gentle journey through Saturn's domain, each revelation adds depth to our appreciation of this cosmic masterpiece. The planet emerges as more than a collection of physical phenomena, but rather as an integrated system where countless processes work together with mathematical precision to create and maintain one of the universe's most serene and beautiful displays. In Saturn's patient dance around the sun, we find a reminder that the most profound beauty often emerges from the simplest physical principles, given sufficient time and space to work out their elegant implications. The harmony we observe in Saturn's system reflects fundamental properties of the universe itself, demonstrating how matter and energy naturally organize themselves into patterns of extraordinary beauty and complexity when allowed to evolve according to physical laws. Saturn serves as a cosmic meditation on the power of patience, showing us how time can transform simple gravitational interactions into symphonies of motion that span millions of years and billions of kilometers. In the gentle glow of Saturn's rings and the measured dance of its moons, we find a kind of cosmic peace that transcends the merely physical. The system operates according to principles that seem almost designed to inspire contemplation, offering viewers a glimpse of the deep mathematical harmony that underlies all natural phenomena. As we drift through these thoughts about Saturn's quiet majesty, we're reminded that the universe itself may be far more peaceful and orderly than our earthbound experience might suggest, waiting patiently for us to notice its gentle rhythms and join its eternal dance. Saturn's auroral displays create light shows that unfold with the gentle persistence of cosmic meditation. Unlike the dramatic flashes and rapid movements of Earth's northern lights, Saturn's auroras maintain their ethereal glow for hours at a time, painting the planet's polar regions with soft curtains of blue and green light that ripple like silk scarves in a gentle breeze. These luminous displays respond to changes in the solar wind with the measured patience that characterizes everything about Saturn's environment, brightening and dimming over periods of minutes rather than seconds. The auroral emissions occur when charged particles from Saturn's magnetosphere spiral down along magnetic field lines and collide with molecules in the planet's upper atmosphere. This process creates photons of specific wavelengths that give the auroras their characteristic colors. But the interaction occurs at such a leisurely pace that individual auroral features can be tracked and studied for extended periods. The displays create a visual rhythm that matches Saturn's overall tempo, where even dramatic phenomena unfold with contemplative grace. These polar light shows extend high into Saturn's atmosphere, creating three-dimensional structures that would dwarf terrestrial auroras in both scale and duration. The magnetic field lines that guide the auroral particles follow curved paths that create complex geometric patterns in the light displays, transforming Saturn's poles into vast canvases where electromagnetic forces paint continuously changing masterpieces of luminous art. The interaction between Saturn's rings and the planet's upper atmosphere creates phenomena so subtle they were discovered only recently through careful analysis of spacecraft data. Ring particles occasionally spiral inward from the main ring system, following trajectories that eventually bring them into contact with Saturn's atmospheric layers. As these particles encounter the increasingly aporized and contribute dense atmosphere, they trace amounts of ring material to the planet's chemical composition. This ring rain occurs at such a gradual rate that it represents one of the most patient forms of mass transfer, operating anywhere in the solar system. Individual particles may take thousands of years to complete their journey from ring to atmosphere, creating a material flow that has been continuing for millions of years without significantly depleting the ring system or dramatically altering Saturn's atmospheric chemistry. The process demonstrates how different components of Saturn's system interact through mechanisms that operate on timescales so extended they challenge human intuition about cause and effect. The rings slowly feed Saturn's atmosphere while the planet's gravitational field continues to shape ring structure, creating a feedback relationship that maintains system stability while allowing for gradual evolutionary change. Saturn's moon Hyperion exhibits one of the most unusual rotation patterns in the solar system, tumbling chaotically through space rather than maintaining the steady rotation exhibited by most other moons. This tumbling motion occurs because Hyperion's irregular shape and its orbital resonance with Titan create gravitational torques that prevent the moon from settling into a stable rotational state. Instead, Hyperion spins unpredictably, presenting different faces to Saturn in patterns that cannot be predicted far into the future. And so our gentle voyage through Saturn's cosmic realm draws to a quiet close. We've drifted together through the serene mysteries of this ringed world, from its whisper-thin ice particles dancing in eternal orbits to its hidden moons, harboring ancient secrets beneath frozen surfaces. Each fact has been like a soft note in Saturn's endless symphony, playing out across billions of years with the patience of geological time itself. As you let these peaceful revelations settle into your mind like cosmic dust, finding its place among the stars, remember that Saturn continues its graceful dance through space, a reminder that even in the vast darkness there exists profound beauty and tranquil order. Sleep well and dream of distant rings sparkling in starlight,